Hi, today I'm going to talk to you about lesson 9.3 or 9-3, angles of elevation or depression, or just simply applications of trigonometry. So now that we know trigonometry, we know our SOHCAHTOA. We know the basics of trigonometry, and we can solve more types of problems. So the first two we're going to learn about are really the only two for this lesson are angles of elevation and angles of depression. So let's just define what those are. An angle of blank is an angle formed between the horizontal line and the observer's line of sight to an object above the horizontal. So if you're looking up, we're going to call that the angle of elevation. Angle of elevation means you're looking above the horizontal, so you're looking at an elevated object. So you can probably figure out, based on the title of the lesson, what the next one is. An angle of depression is going to be the other one. And let's read through that. An angle of depression is an angle formed by the horizontal line and an observer's line of sight to an object below the horizontal line. So if your observer is over here on the top right of your diagram, here's the horizontal, this dotted line. If he's looking down, that angle between the line of sight and the horizontal is the angle of depression. So you can think of this angle of depression means you're looking down. And if someone is depressed, they might keep their head down because, they don't have the energy to lift it up. So whenever you have depression, you might look down. Angle of depression works exactly the same way. So it's a really easy way to remember. And we're going to do problems for each of these to give you some examples. You are going to need to know your SOHCAHTOA, so it might be helpful to just write that down. SOHCAHTOA, where S stands for sine, C is cosine, and T, of course, is tangent. So let's just go through some word problems. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. So there's a rescuer coming down from this helicopter, and they spot someone else over here at point C, off in the distance. And the angle of depression pretty much from the helicopter to that other person is going to be a 42-degree angle. So notice, here's your horizontal going across to point B. And we're looking down at an angle of depression of 42 degrees. So the angle of depression is always defined as being the angle between the horizontal and where you're looking down. But what you really, really need to know is that you already had a horizontal here on the surface of the ocean. So whenever you have an angle of depression, you're going to have two horizontals, one up high where you're looking from, and one down low, which is where you're looking towards. And since you have two different parallel horizontals, you end up getting parallel lines cut by this transversal. Whenever that happens, remember you're going to get alternate interior angles. So this angle of depression here from the helicopter is also, that's 42 degrees, and you also have another 42-degree angle inside this little triangle here, and that's looking up from the surface of the ocean. So it's the same angle. You always got to write it twice. I would highly recommend that you write it twice as soon as you write it the first time. So the reason why you would want to do that is because they're asking, what is the horizontal distance from the rescuers? They're about to drop down to point D. And what's the distance between point D and point C? The horizontal distance from the rescuers to the person. And we're going to round off to the nearest foot. So let's just call that distance X. It's already labeled as X, but we're looking for X. So now that we have this triangle, we can use trigonometry. We have a 42-degree angle. We have, this 42 is opposite the 18 feet. And we're looking for X, which happens to be adjacent to the 42 feet. So which trig function uses opposite and adjacent? It's the TOA, right? So we're going to say the tangent of that angle remember is 42 degrees, is equal to opposite over adjacent. Opposite was the 18. Adjacent we're calling x. This is our problem. How do you solve? You can multiply both sides by x. I'll go through that this one time. X times the tangent of 42, 42, is equal to 18. And of course we need to solve for x, so we still need to divide both sides by the tangent of 42. This cancels out and you're left with x is equal to 18 divided by the tangent of 42. When you punch that in your calculator, you will get the right answer. Let me put my... Okay, so here's one thing. You're going to want to do this. If you don't already know how to do this, go to mode on your calculator and be sure it's in degrees. If it's not, like mine was not, you better put it in degrees unless you want to get the wrong answer. So x is equal to 18 divided by the tangent of 42. That's all you got to do. And 18 divided by the tangent of 42 is, to the nearest foot, it's really just 20 feet. So that's our answer, 20 feet. And remember feet, because everything was given in feet. 18 feet was previously given, so our answer is going to be in feet. So that's how you do problem number 1. Problem number 2 is not going to use angle of depression. It's going to use the other one. And it's saying you have this crossbar of a goalpost, which is right here. And it's 10 feet high, which is the standard height, I think, of a goalpost in football. You're trying to make a field goal from 25 yards out. And you want to clear the goalpost by 1 foot. So really what you want to do is go above that 10 feet by 1 more foot. So you want to clear it. You're trying to clear the goalpost, and you already had 10 feet up to there. And you're trying to go 1 more foot. So what is the total height? 1 plus 10, of course, is 11 feet. 11 feet high is how high you want your ball to clear when you kick it through the goalposts. Now, so we got 1 height. And what are we looking for? We're looking for this angle. This angle x, or you can call it theta if you want. And the other thing we need to know one more piece of information. And it gave us that this is 25 yards away. In football, we tend to use yards. So the first thing you want to do is, we already had feet. And it would be great if we had just 1 unit instead of 2. You don't want to have 2 different units. So you're going to want to make use of the fact that 3 feet is equal to 1 yard. How many yards did we have? 25 yards. So your yards end up canceling, and you're left with 75 feet. So we're going to label this as 75 feet. Then what? We're looking for this angle x, actually. And what do we have? Again, the 11 feet happens to be the opposite side. 75 feet just happens to be the adjacent side. So for these first 2 examples, we're going to use tangent both times. The tangent of some angle x is equal to, this time we're doing opposite, 11 over adjacent, 75. How do we find the angle? We have to do the inverse tangent to get rid of this tangent. We want to find x by itself. So what we end up doing is x becomes the inverse tangent of that same fraction, 11 over 75. So remember, whenever you're finding the angle, you cannot do the tangent. You have to do the inverse tangent. Inverse trig functions like inverse sine, inverse cosine, inverse tangent always provide you with an angle. So let me show you how to do that one on the calculator. You're just going to say inverse tangent. To do inverse tangent, that's the second on top of the tangent. It should say tan minus 1, which is really just the inverse tangent. The inverse tangent of 11 divided by 75 is equal to Okay, and we're rounding to the nearest degree, so that's, let me get out of the glare. So that's going to be about 8 degrees. So x is equal to 8 degrees. There we go. Okay, number 3, moving along. Mount Bunnell. Alice is going to hike to the top of Mount Bunnell, and we're approximating Mount Bunnell with this triangle here. They're saying when she's at the top, she's 775 feet above where she parked her car. So the height above the parking lot is 775 feet. And they're saying from there she can see her car with an angle of depression of 36 degrees. Now this is the tricky part. You need to remember the angle of depression comes down from the horizontal. You got to write it there, the 36 degrees. But remember, this is also horizontal here. So alternate interior angles tells you this is, if that's 36, this is also 36. And hopefully you can see that on the video. It's a little hard to see. That's also 36 right there. Okay, then what? Do we know anything else? What are we looking for? What is the distance she would have to hike down? How would she hike from the top to her car? She would have to hike along this hypotenuse. So we can call it h for a hypotenuse. We can call it anything we want. But that's really the hypotenuse. Let's just say we're looking for the distance x. So the h stands for hypotenuse, but let's just call that distance x. So then what do we have? We want to use the angle inside of this triangle because that's how we use trigonometry. You have to have an angle inside the triangle, or you have to be looking for the angle inside of the triangle. So this angle here is 36. We have 775. That happens to be opposite. But notice this time we don't have the adjacent side. Instead, we're looking for the hypotenuse. So which trig function uses opposite and hypotenuse? That is the sine. The sine of what? The sine of our angle, 36 degrees, is equal to opposite, 775, over hypotenuse, which we're calling x. What ends up happening, if you notice from example 1, these two really just end up getting switched. You can multiply both sides by x, and then you divide both sides by the sine of 36. In the end, you end up just swapping them. X is equal, when the x is on the bottom, you swap them. So x is just equals to 775 divided by the sine of 36. And if you're not sure what I'm talking about, go back and look at example 1, and you'll see that that's exactly what ended up happening. When the x is on the bottom, it swaps locations with this after you do you're solving for x. Anyway, once you do that, you can get your answer. Plug that into your calculator, and you get x is equal to 1318.5 feet. But that was not, okay, so that was part of the question. What's the distance she has to hike down? That's the distance. But there's a two-part question. If she's hiking at a rate of 45 feet per minute, how long will it take her? Let's see. Well, that's how many feet. So remember, distance is equal to rate times time. What are we solving for? We're solving for time. So let's solve that for time. Time is equal to distance divided by your rate of speed that you're traveling at. So her time that it's going to take her is equal to the distance, 1318.5, divided by her rate, which was 45 feet per minute. So we're going to end up getting a time, since this is feet per minute and this is feet, the feet cancel, we're left with just our time in minutes. And that's going to be, how long will it take her? About 29.3 minutes. If you plug this in on your calculator. So just set up your problems very carefully, and whenever you do have angle of depression, be sure to write the angle twice using alternate interior angles. Okay, so that's page 1. We only have one more problem. This one's a little bit longer, not too bad. It's really a two-part problem. Okay, so you have two people playing basketball. Claire and Marissa are both playing basketball. The height of a basketball hoop is 10 feet high, and you're trying to find their distance between these two people, Claire and Marissa. If the angle between one of them in the hoop, the angle of elevation for one of them is 25 degrees, and the one that's closer is going to have to look up at a steeper angle. That's going to be a 35-degree angle of elevation for the closer one. So what you really want to do is use two triangles and take the difference between the two lengths that you're going to find. GTHS. Okay, so let's draw two triangles. We got, let's say this is the 25-degree angle. Someone, whoever's there, I think it's Claire. This is actually Marissa. Okay, so Marissa's standing here, and she's got a 10-foot hoop that she's looking up at. And the other person is going to be looking up at a 10-foot hoop, but not as far away, which means the angle is steeper. It's going to be a 35-degree angle. So what we're going to do is find this side and that side. We're going to call them lengths A and B. Notice you have a right triangle for both of these, and we can use SOHCAHTOA. So this angle is 25 degrees, 10 is opposite. A just happens to be adjacent, which I realize A stands for adjacent too, but just a coincidence that this is also A. So if you want to label this, this is opposite and this is adjacent. So we can say the tangent of 25 degrees is equal to opposite over adjacent. That'll allow us to solve for A. And how do you do it? You swap these two. A is equal to 10 over tangent of 25 degrees. A is approximately 21.4, and remember we were using feet, so this is in feet as well. Well, let's do the same thing for B. The tangent of 35 degrees is equal to opposite over adjacent. Again, this was opposite, and this is adjacent. It's a little hard to read, I know. So it's the same basic setup. Tangent of 35 is equal to 10 over B. That means B is equal to 10 over the tangent of 35. And B comes out to being, sorry, I lost my train of thought. B is going to be a shorter distance, as you would expect, because this person was closer, looking up at a steeper angle. So B was only 14.3 feet apart. So you have to realize what's the distance. If this was B here and A was the whole thing, X is what we're looking for. X was really equal to the whole thing taking away, oh sorry, I just realized it wasn't on the screen. X is this one little segment here. B was the other segment. A was the whole thing. A was the big triangle. So how do you solve for X? It's the whole thing minus the length of the shorter triangle. And this will give you the distance, how far the two students are, the two people are apart. So what is X? X is equal to 21.4 feet minus 14.3 feet. And that comes out to be 7.1 feet that they are standing apart. And that is your answer. So that is how you do one of these. This is actually two different triangles you have to solve for. Get each length. You got A, you got B, and you're looking for the spot in between. So you have to subtract A and B, and then you get 7.1 feet. And that's it for today's video. Please set up your triangles very carefully and label your drawings.